White holes were long thought to be figment of general relativity, born from the same equations as their collapsed star brethren, black holes. More recently, however, some theorists have been asking whether these twin vortices of spacetime may be two sides of the same coin. Today we will discuss with you on the topic, what is a white hole? Welcome back to Signature's Life, and you're watching Signature's Science. To a spaceship crew watching from afar, a white hole looks exactly like a black hole. It has mass, it might spin. A ring of dust and gas could gather around the event horizon, the bubble boundary separating the object from the rest of the universe. But if they kept watching, the crew might witness an event impossible for a black hole, a bulge. Physicists describe a white hole as a black hole's time reversal. A video of a black hole played backwards measures bouncing ball as the time reversal of a falling ball. While a black hole's event horizon is a sphere of no return, a white hole's event horizon is a boundary of no admission. Space-time's most exclusive club. No spacecraft will ever reach the region's edge. Objects inside a white hole can live and interact with the outside world. But since nothing can get in, the interior is cut off from the universe's past. No outside event will ever affect the inside. Einstein's field equations hit physics like a tsunami in 1915, and theorists are still sorting through the wreckage. Beyond describing the force of gravity, his hypothesis also brought a paradigm-shattering message about the nature of their reality. More than a rigid backdrop, space and time bend and fold along with the mass of stars and planets. That insight sparked a race to calculate just how much abuse space could take from the matter that drifts through it. Black holes, the most famous singularities, are regions of space so warped that no exits exist. The outside universe can influence the inside of a black hole's horizon, but the interior can't affect the exterior. While general relativity describes white holes in the theory, no one knows how one might actually form. A black hole coordinates off its bed of space when a star collapses into a tiny volume. But playing this video backwards doesn't make physical sense. An event horizon exploding into a functional star would look a bit like an egg unscrambling itself, a violation of the statistical law, demanding that the universe gets messier over time. Even if large white holes did form, they probably wouldn't hang around too long. Any outgoing matter would collide with the matter in orbit, and the system would collapse into a black hole. For a while, white holes seemed to share the fate of wormholes, mathematically permissible contortion of space-time likely prohibited by reality. But in recent years, some physicists have brought white holes back in an attempt to save their darker siblings from an unseemly death. Ever since Stephen Hawking realized in the 1970s that black holes leak energy, physicists have debated how the entities could possibly shrivel up and die. If a black hole evaporates away, many ask, what happens to the internal record of everything it swallowed? General relativity won't let the information out, and quantum mechanics forbids its deletion. How does a black hole die? We don't know. How is a white hole born? Maybe a white hole is the death of a black hole. On the particle level, quantum randomness takes over and the black hole could transform into a white hole. Such a microgram-sized white hole, being similar in mass to a human hair, would have none of the gravitational drama of its black hole ancestor, but would hide a cavernous interior containing the information of everything it had swallowed in its previous life. Too small to attract orbiting matter, the white hole might remain stable enough to eventually spit out all the information accumulated by its forerunner. Alternatively, the aftermath of a white hole may exist everywhere. To black hole physicists, the Big Bang's explosion of matter and the energy looks like potential white hole behavior. The universe may not contort itself into all the shapes general relativity allows, but some physicists think they should follow this rabbit hole all the way to the end.